Here is fusing AI with AR. It's quite a mouthful. I'm glad Kyle got through it. I'm Stephen Wylie, and I am a Google developer expert from Dallas, Texas. Now, let's see the big green button. There's actually 2 green buttons on here. So let's try the top one. OK, cool. So here I am, GDE in machine learning from Dallas. I'm a software engineer at rewardsStyle, which is an influencer marketing company down there. And in my spare time, I like to fix old arcade machines. Just had a big expo where I brought a bunch of vintage computers to show and let people play games on. I had a pinball party at the house where we had a tournament. About 30 people showed up playing all kinds of old pinball machines, getting all kinds of big scores. I like dressing up in men's clothes and like watching old TV game shows. And then I also happen to have a lot of patents in the realm of AR plus AI. So let's see, does anybody actually do this themselves, the realm of AI plus AR? And I'm here to tell you that, yes, in fact, they do, but not without lots of help. So just to run down a few of these industry verticals where you'll find some interesting applications of here, we've got Capital One, which is where I worked at up until April, where we worked on an augmented reality feature of Auto Navigator. Now, this is cool because basically you can walk up to any car, whether it's on the street or in a dealership lot, hold your phone up to it. It'll identify the make and model of the car. It would connect to Capital One's APIs, and then tell you actually the rate and monthly payment you would be eligible for if you were pre-qualified. And if you were not in a dealership lot, it would actually tell you the lowest price for that car that it would find from any of the surrounding dealers. So it's a really cool application. We trained it on, who knows, probably somewhere nearly 100 million images of cars that we used on that data set. Now, Blip AR was trying to give us a run for their money at that point because they were, I'm sure you've heard of them, maybe the kind of a general purpose AR and VR company trying to develop a lot in the AR space. Well, unfortunately, they went bankrupt. So they're no longer a threat to Capital One's IP, I guess. So anyway, you also have USAA doing stuff with loans, and they're also an insurance provider, so they're probably trying to do fancy things with claims and that sort of thing with your vehicles. In the retail space, you've got Burberry trying to do some important aspects around detecting counterfeits. I mean, it's an expensive brand, so they want to know when people are trying to rip off their products and sell something that's maybe not legit. And then, of course, allowing people to customize the items. Cup Noodles has something a little bit more lighthearted, where if you imagine there's actually cups of ramen noodles, and you can essentially bang on these things and turn them into musical instruments. And so now you can dance to your own beat. And of course, we've got some people in the audience from Wayfair, so I got to give them a shout out. So with Wayfair, you can actually go through and essentially look at furniture into your room or a space in your house and see if the colors match or if it'll fit. Honestly, I'm interested to know how they do the color matching quite exactly, and I'll talk to them about that later. But in sports, now this one's cool. So besides MLB, which is kind of doing mundane stuff like just identifying players and showing statistics, now you've got home court, which for those of you that are avid basketball players or just like to kind of mess around on the court, well, what this allows you to do is actually practice your shots. And from wherever you're standing on the court, if you were to kind of stand back from it, it will actually draw little circles on the court as to where you made the shot, it'll be blue, and where you missed the shot, it'll be red. Not only that, too, but it projects a score onto the backboard that tells you how many baskets you've actually made. So the Home Court app is really, really cool, I think, really well thought out use case for the augmented reality plus machine learning aspect, because of course it's got to know when you made the basket, when you missed it, et cetera. Now, I will say that APIs and frameworks are your friends. There's really, especially for those of you that just want to bootstrap something real fast, there's not much of a reason to go through and do all this stuff yourself. I mean, there's Project Tango that's been around and laid a lot of the groundwork for a lot of the augmented reality stuff. And then, of course, there's machine learning where there's models that are pre-trained already for you, and you just use transfer learning to take your own images or your own particular categories that you want to train, feed it into the model, and then there's your object detection model. So let's go through some key terms real fast. First, we'll start off with the artificial intelligence size. Y'all probably know MobileNet, SqueezeNet, Inception, ResNet. So these are basic object detection models. They're giving you bounding boxes that specify not just what is in the image, but where it is. Now, MobileNet and SqueezeNet are really good for running on cell phones because these things only take up roughly a meg worth of memory on your device. The only downside to MobileNet and SqueezeNet is you're looking at reduced accuracy of classification. So you might get 60, 55% is your best case performance, whereas certainly with Inception and ResNet, you should be expecting in the high 90s for some really apparent type of category. But nevertheless, these are neural networks optimized for the computer vision tasks of object detection. Now, TensorFlow Lite is something really cool that Google's been working on. And what really makes TensorFlow Lite cool is that they have partnered with a lot of the hardware manufacturers to implement the specific opcodes and instructions that take full advantage of that GPU. So as you're looking to maximize the performance from your smartphone to run a machine learning model, you really want to use TensorFlow Lite to run your model on. And then, of course, MLKit, which is kind of on the flip side. So don't necessarily have to write your model. These are things, APIs. Maybe you can call them from Firebase, for instance. They provide resources such as OCR, face detection, various other things that are already pre-built for you. So it really requires minimal effort to get these things up and running. And you can also run these things directly on the device, or you can run them through cloud services as well. Now, in the augmented reality part of the scenery, we've got AR Core, which is a fundamental tool that you'll be using to actually draw the stuff on the screens. In this case, Google's developed it so it's cross-platform. It uses OpenGL. It's basically a light wrapper around OpenGL to do things like motion tracking and scene building. Now, the only thing is it requires a lot of boilerplate code, I feel like. For those of you that are used to OpenGL, then great. Me, not so much. It was quite an effort just to draw a piece of text and stick it to some random spot on the screen and have it kind of be tracked to certain areas. Not the easiest thing in the world. Luckily for us, there's SceneForm. Now, SceneForm is a specific SDK for Android that saves you from having to learn OpenGL. Makes it really easy to do this stuff if you just know Java and you understand a little bit about the API that it provides. So let's talk about now how to establish your Android app. I've got a little flowchart here of the steps that you will go through in order to do this. So at a glance, you'll install the prerequisites, you clone the code, the repo code, especially for TensorFlow. You open it up in Android Studio, edit it a little bit, build some stuff with Bazel for your object tracking library. Then once you've built the object tracking library, you can add in the augmented reality code, rebuild it using Android Studio, and then it's time to make your money. Because we like that cash money, y'all. It's a reference from DroidCon Berlin, but anyway. So in terms of the prerequisites you need, you want to get the latest versions of Android Studio, API level, which I think they've got Android 10 preview out now, but it's OK if you use Android Pie. So 9, I believe, corresponds to version 28. You can use the Android NDK for your C++ compilation. Then, of course, you need Gradle for your builds involving the latest Gradle plugins. And then finally, Bazel. Now, Bazel is a really amazing, essentially distributed compilation tool that's supposed to allow you to compile and build really, really big projects with speed and ease. Unfortunately, when you're on a laptop, sometimes you just want to turn your head the other way, I suppose, while it's going on. But some of the other things you'll want. Now, in my experience with doing this, you want a specific version of the Java JDK, in particular 10, because you get certain build errors if you use 11, certain other build errors if you use 8. It's a really weird scenario out here. And then otherwise, if you're building in Windows, well, it might be easier to just install the Visual Studio Community Edition 2019. But if you don't feel like installing a huge IDE, then you can simply get the Visual CPP build tools as specified here. Then a specific Windows 10 SDK, because you want to use this one, because there are files that it contains that might not be present in future versions, and Bazel build is going to complain if they're not in there. And so, once again, weird Windows business. Obviously, I'm a masochist. I just like banging my head on the table a bunch while I work. So besides Windows 10 SDK, you want the .NET Framework SDK, and then a real shell. Guys, on Windows, please, I hope you have a real shell. Even Git Bash is good. Actually, I don't even use MSys2. I use Git Bash. And then pick your poison. You can get the TensorFlow source from GitHub, just clone it, or you can get it from Docker. Just be aware that if you get it from Docker, you're going to have to install the whole Android Studio, or not really Android Studio, but the Android build tools, including the NDK, onto the Docker container. Not really that hard to do, to be honest. So either way is fine. So let's go on to talking about what you need to do to the app code to make it work. So it's a very specific path you want to get to in the TensorFlow code repo for where to get to an example that's a really good example for getting started with TensorFlow Lite on Android. And it's this one listed right here at the top, Lite Examples Android app. That's the path you want. Now, it's up to you. If you want to copy the code to a different folder so you don't spoil the original code, then that's fine. Now, how many of you are Android developers in here? You got like about 4 hands went up, I think. So anyway, I'll explain real quick that Gradle is basically your dependency manager. Whatever you want to pull in terms of libraries or things you want your code, you want your Android application to have, needs to come through Gradle. Luckily, to add scene form to it is basically adding one line of code to essentially a JSON file, and then you specify that scene form needs to be built. And then next time you build, it'll download it, it'll put it in. Speaking of Gradle, you got to update the Gradle itself to feature the latest version of the Android SDK build tools for API version at least 26. Then, in your Android manifest file, Android manifest defines a lot of things about how your application actually behaves. So, for instance, it says which icon appears in the launcher, like when you open up the phone, see the applications list, which activity ends up being correspondent with the icon. And then, of course, your permissions. So permissions include things like location or Wi-Fi or internet access, or especially augmented reality. So you need to add augmented reality permission to your application. Then we're going to make a new layout incorporating AR fragment. Whoa. Hold on a second. You're saying AR fragment, yet we're talking about the TensorFlow Lite code repo. OK, so let's step back for a second. AR fragment actually comes from, you can get it from the SceneForm code lab. So essentially, you can combine the code from the TensorFlow repo with the code from the SceneForm code lab. Except what you're going to do is modify it a little bit, because what happens with the code in TensorFlow is it is showing you, essentially, you have the view from the camera, which is drawing the bounding boxes around objects that it's detecting. And then it's also having little displays at the bottom where it's saying, here's the item, here's the confidence level of it. Well, what we're going to do is we're going to swap that out with the view from the augmented reality fragment, which is now going to be taking the camera, the same camera input, but it's also going to be instantiating all the tools that allow you to kind of, when you first start an AR app, you swipe the floor a little bit to find the points. You will then essentially be able to draw 3D objects on the screen as you see fit. So then you use this new layout in your camera activity, which is essentially the thing that gets run when you start the Android app. You can make it a separate class if you want to keep the original stuff. You can update the manifest with the new activity, of course, so that it launches when you expect it to. And then you got the detector activity, which is what you're actually using to run your object detection model. So make sure the object detector activity is properly talking to the augmented reality activity. And this will allow for the objects to be drawn on the screen when and where you expect them to. The good news is, with Gradle, you can actually have it download all the machine learning model assets you need. So if you have resources you're looking for, like maybe a model that's already on TensorFlow Hub, you can get it from there. You're looking for the object, the actual category list that goes along with this model, so you get it from there too. And so everything is pretty straightforward when you just use Gradle to handle the stuff for you, which is even going to be highlighted later on during the AR part. So let's take a look at, well, this is going to be fun. Can we play this or not? Nope? OK. I'll describe it then. So what's happening is I've got a shelf full of old CRTs, and I'm walking by it. And this thing is drawing bounding boxes around the CRTs, except the bounding boxes are of different colors, and they're all flickering everywhere because you don't have the object tracking working. And so the object tracking is what allows you to track an object smoothly as it progresses along the scene. But what's happening here is that every time it gets a new frame, it's kind of detecting these objects in random order and has no idea that anyone is anyone that it saw in the past. And so it's kind of arbitrary as to what it's doing. Now we want to correct that before too long, or else it's going to be really difficult to attach an augmented reality object onto any of these things. So let's actually get this going now to build the object tracking module. Now this is where we need Bazel. which is going to smooth the object detection out and improve the tracking. So to do this, you're going to define a couple of parameters in your workspace file. Now, the workspace is way down in the root of your TensorFlow code. You define the Android SDK and the NDK. Assuming you've already downloaded these, just put the paths in, specify them. And you can either omit or leave in the API level and build tools, and it's fine. Then when you cd into TensorFlow, you run bazel build. Now here, you specify the binary that you're looking to build. You want to build the TF Lite demo in the Android folder of TensorFlow Lite examples. And once you do this, you're basically specifying the build target. But the reason you want to run it from all the way up at the top of your TensorFlow repo, there's various other dependencies that are going to come in and be important for this thing to actually work. And if you run it from all the way down in your Android code, then Bazel's not going to have any idea where they're coming from. You're going to get a lot of build errors. So please don't do that. And then the funky Windows business I mentioned earlier. So there's another funny thing that happens where there's problems if you use names. Like if your user account has a space in it, like Stephen Wylie. Not going to work. It's got to be just Stephen. It's got to be one word, or else you end up getting some weird errors in that realm. The other thing with the dependencies that I mentioned as well for the C++ SDKs, you got to possibly be aware that you might need to copy some files between different versions of the Windows SDKs, and that's usually buried somewhere in program files or something crazy. And then pray hard, because it's Bazel. But here's what success looks like. When you finally get it all going, you see that there's not too much in the realm of errors other than just some ambiguous priorities. Everything seems to have compiled OK. And then you get down to the bottom, and you see that it took about 213 seconds for everything to all run. I'm sure it'd be a lot faster if you used a big old GCP cluster or something like that. Anyway, now the code is, I'll have to describe it for you again. I'm panning by the same row of these old computer monitors and things like that, except now the boxes are not flickering. Or maybe like one or two will flicker here and there, but essentially the object tracking is now keeping the blue box on one monitor and the purple box on another monitor, and everything looks smooth now. It's properly detecting which object is where on the scene with your new code that you've run with Bazel. Now, let's talk about adding the augmented reality feature of this. So this is where we want to do a hit test. Now, the hit test is basically, well, I'll get into that a little bit later. For one thing, you don't want to use Bazel anymore because there's actually problems where if you try to build with Bazel with the dependencies that AR Core requires, you're going to end up not being able to find one of the dependencies. It's like nowhere on the internet can I find the name of this thing that's actually telling me. So luckily for you, what you can do is you can take the object detection, object tracking model from your user directory inside of your computer and grab it from the folder that Bazel made at build time, and then drag it into the JNI libs folder that's specified up here on the slide. And the JNI libs is basically where you can keep processor architecture code specific to your CPU that you're building it for, whether it's like ARM EAB IV7 or V8 or something like that. You can specify which mobile version, or like even x86 for x86 phones. You can specify all those folders for specific build codes in there. Set the parameter for CPU architecture in Gradle as well to make sure that Gradle knows to build this thing and include it. Then, SceneForm plugin is something you can download inside of Android Studio. So with SceneForm plugin, you can actually build up all the resources for your 3D object model. Now, the problem kind of happens sometimes when you have a discrepancy in the version of SceneForm that you have installed versus the version of the Android Studio plugin. So probably before you get started, you want to make sure these are reconciled with themselves, because if they're not, you might get weird issues, such as the SceneForm plugin will never build the SFB resource file that needs to actually be rendered by the Android operating system to make your model show up in the program. So turns out that you can also use Gradle for that too. You can use Gradle, simple, I think, a 4-line instruction in your JSON file to create the instructions to create the SFB assets. Now, essentially, there's like 3 realms of this. There's the OBJ file. For those of you familiar with old-time 3D Studio Max, it's like a basic 3D object format that you can just draw anything arbitrarily that you want. There's SFA file, which is basically like the metadata for your object model. And there's SFB, which is essentially like your OBJ plus your SFA into an SFB. And that's the ultimate thing that the Android app needs to be rendered to make this work. Then we're going to add the augmented reality code to the class called multi-box tracker. Now, multi-box tracker is one of the other classes associated with drawing the bounding boxes on the screen. Now, what we're going to do here is we're going to perform that hit test. So basically, when somebody taps on the screen, it's going to send a notice to the operating system to add a point right there and determine where in space it is relative to the scenery that you've tracked up. And then once it does this, it'll actually, for the code implementation that I've done, it'll take the whole bounding box, the corners of it, kind of test the corners, and then make something that is in space relative to the center of it. Now, let's go on and see what all this looks like. Now, the final product, it gave you a little glimpse of it anyway, but as you can imagine, I'm essentially in a hotel environment, and there's chairs and tables, and as I spot the chairs, it's going to try to place an android, like Andy the android, into one of these chairs, which is kind of neat. And then as I walk around the table, you can see that the android will actually stay in the chair. And so that's the implementation of the augmented reality plus artificial intelligence. And so now it's time to go make your cash money. But first, I want to talk to you about some of the pitfalls that you'll encounter in this realm. For one is battery life. Like, we don't want you turning your phone into an incendiary device, but that's just about what happened when we were first trying to implement this thing, because we've got AI plus AR trying to run at the same time. So what you can do is throttle your artificial intelligence smartly, because you think about, as you're doing the object detection, there's going to be a lot of frames coming in that are blurry because somebody's walking from spot to spot. Well, that's kind of silly to be doing object detection during that time, because you might not get a good reading depending on how your model's trained. So maybe that's a good time to turn off your AI until the accelerometer data shows that it's slowed down enough for this thing to be workable. The other one you can do to consider is the depth and the size of the object. And this kind of harkens back to what Forrester was talking a little bit about earlier in the day, is that you want to consider the model you build, your OBJ file, might be the size of a dollhouse, or it might be the size of the stage. And so it's important to consider from the customer experience, if they're going to be trying to manipulate with something at this level, and then all of a sudden something pops up that's so big they got to lean back this far to see it, then it's going to be really problematic for your users. So one of the cool things you can do here is to essentially correlate the bounding box with your hit detection to make sure that the bounding box is actually a reasonably large size, and the hit detection will properly manifest the object in the middle of that bounding box that you're seeing. Going on a bit, there's sensor drift. So as you're holding up your phone, you might realize that you're placing an object somewhere out here, and then you turn around and, well, now it's not there anymore. So the augmented reality is relying on point clouds using basically contrast from various corners and contrast in lights and intensities of things that it sees from the screen, plus hardware sensors like your compass or a gyroscope. And unfortunately, these compasses and gyroscopes are likely to drift with lots of motion. And objects that are anchored to the world space then are likely to totally wander off. So what's the good solution? Well, one thing is you can make sure that your environments that you're doing this in have good contrast and enough corners that you can see in every aspect of your frame as you kind of pan around. Also, attaching objects to anchors is a good solution. If you have one anchor ahead of time, you attach all your objects to it, and this will help conserve memory. And you want to be able to scan enough of the scene ahead of time before drawing the AR. So normally, when you use this example app, it's going to show you a little hand holding the phone, trying to coerce you into waving it around the floor a little bit or around something that gives the camera and AR features a good notion of what the room looks like. So besides all this, tracking multiple objects. So as you're looking at multiple objects, object detections could be missed, false, positives, or even switch IDs during the middle of it. And so you can discover correlations between objects moving on camera, such as either pairwise dependencies or maybe using hypergraphs. That's an advanced topic of research I'll probably leave for the Google Brain team. Of course, multiple object tracking is easier when you use the TensorFlow Lite demo library that Basil just built for us earlier. But if there's no library for this, then you got to code it yourself. Otherwise, it's going to be really difficult. So this is where it's really important to take the time properly to set up your Android NDK to do your native C++ builds, and also set up the libraries required to get all these things done. Anyway, that's time, and this is also the end of the presentation. So thank you so much, and ready for questions.